Hi! In this video, I plan on explaining how we actually train the neural network after we've generated wave files and noisy bathymetry files and all that jazz. So first off, we need to move the generated data from at/bellhop into a new folder which we haven't explored yet called 3D. Now this was pulled from a guy named Dinesh. He's the one who initially made this neural network, and this code is from his GitHub. If you go to bathymetry, if you go to DP195 right here, you can find it. For my personal ease, I moved it into my folder. So open up agc26/3D, and then paste the generated files into it. In this situation, I've only made 2 files for training data. That's a little weak. You can't actually train a neural network with 2 training files, but for the purpose of this video, I wanted it to be fast. So here's the noisy data. We have a bathymetry file, environmental file, a wave file, everything we need for a good neural network. So the first file you want to open is input_output_3d.m. This file searches through the current folder and finds all of the bathymetry files and all of the wave files, or sound files, and associates them together. So I'm going to run that. It's going to give me an issue or an error. That's what I like to see on a video, so I can explain how to fix these kind of errors. This is entirely planned. So unable to perform assignment because the size of the left side is 10,000 by 1 and the size of the right side is 500,000 by 1. This is a reoccurring error and one of the things that needs to be fixed with the neural network. The input full is not dynamic. You have to set that per file, so I'm just going to change that to the 500,000 it requests, and then rerun this, and then it works. And that's one of the issues with the file sizes changing when you generate them. There needs to be a way for this input to pull that data size before it creates its input array. And it creates input full, and it creates output, and these are the bathymetry files and the sound files needed for the neural network. The next file you want to open up is nnet3d.m. This is generated by the Deep Neural Network Toolbox that MATLAB provides, and if you're running this for the first time, it's going to pop up an error. You need to actually download that toolbox. I believe that's under apps, or yeah, it's under apps, under Get More Apps. I have all of them right here, neural network clustering, fitting. So all of that I already have downloaded. Anyways, I'm going to run that. It's going to pop up a little visual of the neural network, and a little visual of it training. Hopefully. There it goes. There it goes. So as you can see here, this went really fast. Normally the neural network would not go this fast, but having only 2 data sets kind of speeds things up a little bit. So as I've explained before, this is a shallow neural network, meaning there's a hidden layer. In this situation, there's also an output layer, and then the output. So here we go. Input to a hidden layer, to an output, to the output. This checks the performance, the gradients, and does validation checks. As well, it tests over a certain number of epochs. So one of the limitations of this neural network is it's very slow to train data when you have more than 2 points, and I'm talking when you have thousands of points. It gets really bogged down. I'll talk about potential ways of mitigating that later when I talk about OceanFace, but for now it's on Windows version of MATLAB and it's slow. So this is the visual of how to train the neural network. If we exit out of that, we can go to the next step, which is result.m. And another current issue with this code is it's very not dynamic. In fact, you have to specify where exactly you are in your location, where exactly you are in your current working folder. So the easiest way to do that, if you click up here, you can Control-C, copy that, and then everything that has a location, you just have to change. So that's RET equals read BTY 3D plot. You change that. That's this bracket y xf af equals sim. You have to change that. And on top of that, you have to add, for this first one, the read bathymetry file, what your actual bathymetry file is, what your non-noisy, what your perfect, beautiful, potentially coarse bathymetry file is. So in that case, it's in this folder, and it's Weymouth 3D.bty. As well, you have to give it a sound file to run through the neural network and generate a bathymetry file from. In this case, to showcase a current limitation, I'm going to actually give it a training data file, which is copy of to Weymouth 3D RTS RD. Get that full name. I'm going to choose the first one. 1 underscore RR underscore 1 dot WAV. And theoretically, if this neural network was perfect, by me giving it this, literally this training data set, it should output a perfect map. Another thing that needs to happen before you can run this result script, you need to go back into the main AGC26 folder, grab this Weymouth 3.bty file, and copy and paste that in here. The reason this isn't in here in the beginning is because when you run input underscore output underscore 3d.m, this searches for bathymetry files right here, l equals directory.bty, and this would interfere with it creating its input and output arrays. So anyways, these are the files that need to be changed before you can actually run anything. I'm going to quickly replace every available instance of these files within this code. So I scroll down to line 28. Replace this with the training data sound file. Scroll down again. Replace it again. And what this neural network is attempting to do is generate the bathymetry files, generate a new bathymetry file based off of the training data, and compare it to the actual perfect, fantastic validation bathymetry file. Replacing that's one. And there we go. So we click run. We run into the error of too many parenthesis files. Or potentially not. We remove it for now, and then we view the results. It's loading, but it should flash a series of images. As such, the ground truth, which is the good bathymetry file, versus what it actually generates. And as you can see that flashing on the screen, the ground truth is the very, the very surface, the thing that actually looks like the inversion of the ground of the ocean floor. And this parabola right here is what the neural network currently constructs. So this is bad. This is an issue. The neural network is constructing a parabola when it should be constructing this inverted ocean floor. If we move this around, we can actually see how it's an ocean floor. You can see This, you can see the depths are increasing like this. That is a bellhop setting that, as the depth goes down, it increases in positive numbers. That's why I'll put it like this. However, this reconstruction does not reflect that. So that's something that I believe to be an issue with the delay and sum file. And I believe that's an issue with how the audio files are actually generated. No training data should be that bad compared to the original, as, again, it's training data. Finally, to fix this error down here that I just commented out, this specific line asks just for the WAV file. If I run it again, theoretically will work. And this is just another one of the outputs for this neural network. So to recap how this works, you run the input_output_3d.m file with your generated training data. That's the noisy bathymetry files and the noisy wave files. You run nnet3d.m to generate the neural network. And then finally you run result based off of a chosen bathymetry file and a chosen sound file, the chosen bathymetry file being the ground truth, the chosen sound file being ideally actual sonar pings, actual sound files from tests. In this situation, it's training data to show the limitations of the neural network as it is. And if all goes well, you get a great map in the .v2i format. That's all. Thank you for watching this long video. Signing off.